Right, so in chapter 1, we looked at what we call the addition and subtraction properties of equality. And those said you were allowed to add the same number to both sides of an equation or subtract the same number. Well, the same rule applies if you have an inequality. So if you have something like this, let's make that a less than or equal to 12. To get the x by itself there, what would you have to do on both sides? Add 8. Just like it was an equal sign. Right? We're going to do it the same way. We'd add 8 on both sides. Okay, how do you read that one? And this will be the first thing on your guided notes. How would you read that?
A is greater than B. No, it's less than B.
Less than B. Yep. So A is less than B. So on your guided notes, that first line, you're just going to put A is less than B. And what does that mean about its position on a number line? Like if you had 2 spots and you were going to mark them, which one would be A and which one would be B? Yep.
The first one would be B. Or A.
So let's just, we can put a few numbers in here. This is 0. So which one would be which?
The one to the left.
Mm-hmm. Would be
B.
no, because that would mean B is greater. All right. If you want, B is no, it would mean A is greater. We don't want A to be greater here, so we don't want to put B on the left. Where do we want to put B?
On the right.
On the right, right? If B is bigger than A, or you could say A is less than B, same thing. That means A has to go on the left, and then B would be on the right. Now, whether they're negative and positive, we don't know. But A definitely has to be to the left of B. Right? That's what it means to be less than. A is to the left of B on your number line. And I think you guys already have that written on your notes. All right, let's look at this one. How do you read that one?
Which one?
That part right there. How would you read that?
That's a greater than symbol.
That's a greater than symbol, yep. And so how would you read the whole thing?
C is greater than D.
Exactly.
I didn't see the C.
Yeah, C is greater than D. Yep. Now, what would that mean if they were on a number line? If C is bigger than D.
It would be before the D. C would be on the first and D would be on the second.
So you'd put C here and D here?
No, on the first spot. D on the first one, C on the second.
Oh, D on the first spot, C on the second. Yeah. So this would be D. Not B. So this would be D. And this would be C. So if C is bigger than D, it means it's further to the right. So anything that's further to the right on a number line is bigger. And so C is further to the right on the number line, so it's bigger. It's bigger. All right, so that's kind of an important idea just to understand. The further to the right you go on the number line, the bigger the number gets. If you go further to the left on the number line, then those are the smaller numbers. Okay. Any question on that? All right, so what does it mean to solve an inequality? It basically means to find the solution set. Notice it doesn't just say find the solution. Why do I use the word set there? Anybody know? Well, when you think of a set, what do you think of? Like if you have a set, what kind of comes to mind with like how many things would be in it? If you have
A set of cards.
like a set of cards, right? So how many are in a set of cards?
4. There's about 40 cards. 50.
Yeah, it's 52, right? So it's 50, I think it's 52. Yeah, 52. So when you think of a set, you think of more than one, right? You don't think when you have a set of stuff, you don't
A set of shoes.
like a pair, like a set of shoes, right? There's 2 of them. When if you just have a shoe, I wouldn't really call that a set. You're missing one. So a set means usually that there's more than one. And when we're solving inequalities, there generally is always going to be more than one solution. Okay, let's look at this one. What's a number you could plug in for x that would make that true?
That is. You could plug in like 8.
You could plug in 8. 2 times 8, 16 is bigger than 10, so 8 is a solution. What's another number that would be a solution? What is it?
9.
9, yeah. 2 times 9 is 18, and that's bigger than 10. So there's another solution. You could plug in
10.
10. 2 times 10 is 20. That's bigger than 10. So the point here is there's a bunch of numbers that are the solution. And we call those a set. So every number that makes it true is this set of solutions. Okay, so it says when solving an inequality, and then you guys have a couple lines to write it down. The goal is to get the variable by itself. I don't even want to say preferably on the left side. I almost want to put always on the left side. Okay, we always want to end up with the variable on the left side. If you don't, it's not that it's wrong, but if we have to do any graphing, it's going to be more confusing if we don't have it set up letter, symbol, number. So I would say almost always you want to get the variable on the left side. But technically, you're not wrong if you don't. But you should. Okay, so what we'll do now is we're just going to work on a few examples. There's really no more explanation as far as like the steps because you already know the steps from solving equations. It's the same steps. We're not going to get as complicated as Sam today, so you're not going to have a distributive property, combined like terms. Eventually we will. But today I don't think we're going to get quite that complicated. So it's just like solving equations. I basically just said that to you. Okay, does everybody have the underline part? All right. So I think we're going to have enough time. I'm going to let you guys try each example unless we start to run out of time. But that's example 1. Okay, x minus 8 is less than negative 11. So go ahead and try it. And we'll walk around, and when you think you have the answer, just let us know, and we'll check it for you. All right, let's take a look at this one together. Okay, so this is a one step, and the goal is to get the x by itself. What side is the x on right now? Yeah?
The left.
The left, perfect. I like the x on the left side because we always want to try to set it up letter, symbol, number. What's preventing the x from being by itself right now? Yeah.
The negative 8.
The negative 8. So how are we going to get rid of a negative 8? Like what operation do we have to do on both sides?
Add 8.
Yep. I'm going to add 8. Add 8. I'll make sure I get the calculators out when I give you guys the next one to do. But what's negative 8 plus 8?
0.
0. That's gone. So what do you have on the left-hand side now?
X.
Just x.
Oh, yeah.
then you're less than. And now negative 8 plus, or negative 11 plus 8, some people have some trouble with that.
-3.
That's negative 3. Okay, if you're at negative 11 and you add 8, it's becoming less negative. It's moving to the right. It's becoming positive. Well, getting positive, but it never quite makes it. So we get x is less than negative 3. Okay, what kind of circle after we make our number line? Yeah, it's going to be an open circle on what number? Negative 3. And then which way are we going to shade? Yeah, as long as it's set up letter, symbol, number, just go by the direction that that points. If it's not letter, symbol, number, you can't do that. Okay, I know I keep saying it, but it always happens on the test. Somebody doesn't set it up the right way, and then they reverse them, and then they get them all wrong. So it's got to be letter, symbol, number. Okay. And there's your graph. So that's example 1A. All right, why don't you guys try 1B, and I'll get the calculators out. All right, so in this one, what letter is the side on?
It's on the left side.
Yep, the letter's on the left side. That's where we want it. If it wasn't, we could still solve the problem. We'd just probably fix it at the end, so we put it on the left. And what's the one step we have to do on both sides to get B by itself?
+2.
Plus 2. Plus 2. What's negative 2 plus 2? Cancels out. What do you have just on the left side now?
B.
Just a B. And now negative 9 plus 2.
-7.
Negative 7. When you get the letter by itself and you have just the number on the other side, you've solved it. That's what solve means. So that's solve. Now graph means to draw it on the number line. Okay, so we've got negative 8, negative 7, negative 6. That's enough numbers. What kind of circle do we need this time? Closed. On what number?
7. -7.
Negative 7. And which way, thank you, which way are we going to shade?
The right.
Yeah, we're going to shade to the right. So we just shade it in. And that's it. Did I mention yesterday how that would be on Edge Elastic? Like you'd have buttons you click? Yep. You'll have a button, a closed circle right, closed circle left, open circle right, open circle left. And you'll just click the one you want, and then you'll be able to click on the number line, and it'll draw the arrow for you. And the number line will already be numbered. Yep. All right, let's try that one. So y plus 8 is less than 5. Okay, y plus 8 is less than or equal to 5. Okay, so this was another one-step problem. Again, what side is the letter on in this one?
Left.
It's on the left, so that's good because that's how we want it. We are going to do one where it's on the right in a minute. We still solve it the same way. Okay, but I'll show you something when we do that. All right, so the y is not by itself because it has that plus 8. What do we have to do on both sides to get rid of a plus 8? Yep, we're going to subtract 8. Subtract 8. And what's positive 8? Minus 8. 0. And that leaves us with what on the left?
Y.
Y is less than or equal to?
-3.
Yep, 5 minus 8 gives you -3. Okay, so there's the solve part. Now the graphing part, I'm just going to put my numbers over there so they're out of the way of my answer. What kind of circle do we need? Closed circle. On what number? -3. And then which way do we shade?
To the left.
Yep, I'm going to shade to the left. Any question on that one? All right. Now, in the next one, something like this is going to happen when you solve it. You're going to end up with like 4 is greater than y. Okay, so you're going to end up with something that has the variable on the right. We need to fix it, so it's letter, symbol, number. So we always fix it right at the end. So what's the letter in this problem that we want on the left? We want the y on the left. What's the number we would want on the right? 4. And what symbol was what was it pointing at originally? It's pointing at the y. So when we rewrite it, it still has to be pointing at the y. That's how you rewrite your answer, to put the variable on the left. So it's like an extra step you have to do at the end. Any question on that? All right, so let's try that. And example 2b. Okay, so take a minute, try that one, and when you're done getting the letter by itself, then do that extra step at the end and put it on the other side. Okay, so this one a little bit different because now we've got the letter on the right side. What's on the right side with the m that we don't want there? Yeah, we don't want the 1.4. So what do we do on both sides to get that 1.4 onto the left? Yep, subtract 1.4. When you do it on the right, it's gone. Now on the left, that's a negative number minus something. When you minus something from a negative number, it's going to go even further into the negatives. So it's going to go further to the left. What's negative 8 minus 1.4?
Negative 9.4.
Negative 9.4 is less than m. Okay, so we solved it. And technically, if the problem only said to solve it, you could leave your answer like that and you're not wrong. But remember what I wrote down? Preferably, we want to get the letter on the left when we're done. Okay, that's usually how we want to do it. So, where is it? Okay, what's the letter that we want on the left side here? We want the m on the left. And what's the number we want on the right? Negative 9.4. And what was the inequality pointing at? It was pointing at the negative 9.4. So it still has to point at that. Okay, so these are the same answer. It's just this one on the right, we like it a little bit better because this symbol tells you something. What does that symbol tell me? Yeah.
It's greater.
So it's a greater than symbol, but it tells me something. It helps me to do something now. What does it help me to do if I set it up that way? Yeah.
To graph.
Right. It helps me to graph it because it points in the direction I need to shade. All right. So this time it's a decimal. So what we'll do is we'll do like negative 9, negative 10, negative 8. Where are we going to put the negative 9.4? Like, where would the circle go? I know it's in between, but can anyone describe kind of where in between, Sam?
Roughly in half of the negative 9 and negative 10.
Right, it's about halfway. It's a little bit closer to the negative 9, but anywhere right in there. I should have asked, but it is an open circle because it doesn't have the line under it. And now, which way do we shade? To the right or to the left? Yeah, we're going to shade everything going to the right. Okay, so it had that extra step where you had to fix it to put the letter on the left at the end, but that was it. And I know a lot of these seem really, really simple, kind of like almost boring because they're really easy. But we do get to some harder ones. I think that's when people start to get a little bit confused because sometimes they don't understand the really easy ones. Okay. Any question on that? All right. So let's try this one. Do you guys already have the word problem written about the circuit overloads? Okay. So it says a circuit overloads at 1,800 watts of electricity. Okay, so that's when the circuit breaker would trip. So what does that mean then? How much electricity can you use and not overload it? Yeah?
It would be 700 watts.
Well, you could use 700 and wouldn't overload it. What's the most you could use and not overload it? Yeah.
1,799.
Okay, so you could even use 1,799.2, right?
Yeah.
Or 0.3, 0.4. You can use it right up to 1,800, but it has to be less than it. So if it's 1,799.99999, that's okay. It just has to be under 1,800. So it says you're going to plug in a microwave that uses 1,100 watts of electricity. We want to write and solve an inequality that represents how many watts you can add in addition to the microwave without overloading it. All right? So basically, what we plug in has to be less than how many watts?
1,800.
It's got to be less than 1,800. All right? What if we already plugged in?
1,100.
Right, we've already plugged in a microwave that's 1,100. So that's one thing we've already plugged in. And we want to be able to add more, and we can. We don't know how much more we're going to plug in right now. So if I don't know how much it's going to be, how could I represent it for now? Yeah, I'm going to add this much more to it. But when I add that much more, it still has to be under the 1,800 or the circuit is going to overload. Okay, so this is what we've already plugged in. That's how much more we want to add. We don't know how much more, but we want to add more. But we got to make sure we stay under 1,800. Okay, so we've done that. We wrote the inequality. Now, we have to solve it. Okay, how am I going to solve that? What do I have to do on both sides to get x by itself? Yeah.
Subtract 1,100.
Yep, we're going to subtract 1,100 from both sides. That's going to cancel. Marie, what do I have on the left-hand side now?
X.
Just the x, less than. And what's 1,800 minus 1,100?
700.
700. Okay, so explain to me what that means. X is less than 700. What does that mean in terms of our word problem? That's what I want to know. What did we just figure out? Yep.
You can plug in something that's no more than 700.
Exactly. You can plug in anything that's under 700 watts, and it will trip the circuit. Okay, it can't be more than 700. It's got to be under 700. So now that we know we have to be under 700, we can look at different appliances and we can see if we could add them or if we can't add them. Could we plug in a clock radio with the microwave?
Yeah.
Yes. So what does it say in addition? Which of the following? Clock radio. So I'm going to write yes. Now we're looking at each one of these separately. Okay, not plugging in a clock and then plugging in the blender with it. All right, so now we take the clock out. The clock's unplugged. Could we plug the blender and the microwave in? Yes. We could do both of those. Could we plug in the hot plate with the microwave? No. That's too many watts. Okay, so it's gonna trip the circuit. How about the toaster? No. Would use too much electricity. What do you notice about the two things that use the most electricity? What kind of things are they? Yeah?
A heating element.
Yeah, things that heat. All right? Anything that heats up generally uses a lot of electricity. Whether it's a hairdryer, that uses a lot of electricity. If you have like a space heater and you plug it in, that uses a lot of electricity. Things that get hot and heat up definitely use a lot of electricity. Electric fireplace, if you turn the element on so it does heat, that's like basically like a space heater. It uses a lot of electricity. A radio doesn't really use much of electricity. Okay, just a radio. It doesn't heat. It's not what it does. The other thing that uses some electricity is a blender because it has a motor. Right? Anything with a motor that also can use a lot of electricity. Clocks don't have a motor, but like a blender would. Maybe if you had like
A microwave has some.
yeah, microwave. That's a ton of electricity. Usually microwaves, they're definitely over 1,000 watts is probably like on the lower end of a microwave. But yeah, microwaves use a lot of electricity. Yeah.
Then what about air conditioning? It just cools things down.
So the cool air comes out the front, but what comes out the back of it?
Hot air.
A lot of hot air, right? So there's a ton of hot air that's made from an air conditioner because it has a motor in it. So an air conditioner would probably use more electricity than all of those. Like the air conditioners use a ton of electricity.
I didn't know it produces hot air.
Yeah, yep. That's how an air conditioner works. It basically blows the hot air out the backside. So like if you just put an air conditioner in the middle of your floor and you turn it on, the room wouldn't get cooler. Because the problem is the cool air would come out the front, but then there'd actually be more hot air coming out the back. So if you just plug an air conditioner in the middle of your floor and just let it sit there, it's actually going to heat the room up because there's going to be more hot air coming out the back than the front. The only reason the air conditioner really cools your room is because usually you put it in a window and then the hot air goes outside and the cool air stays inside. Yeah, that's the difference. But yeah, a lot of electricity with an air conditioner. Lights don't use a lot of electricity, especially if they're like LED lights or fluorescent lights. They don't use a lot. Some lights might only use like 10 or 15 watts. That's not very much at all for a light. Yeah. All right. So any questions on that? All right. So we still got about 12 minutes. So I'm going to have you guys try example A and B. Okay. If you can't read it, it says t minus 3 is greater than negative 2. And then the one on the right is p minus 3. Okay, we haven't talked about that today, but we've done it before. Minus a minus is greater than 10. Okay, so try those two, and then I'll check in with you. We'll do them, and then that'll be it. All right, let's look at extra example A. What do you have to do first to get t by itself?
9 and a positive 3.
Yep, you got to do a plus 3 on both sides. And what's negative 3 plus 3?
0.
That's gone. Now, what's on the left?
You would have negative 1. Positive 3.
On the left?
All left side. So take
T. Okay, so T, and then greater than positive 1. What kind of circle would you put on the 1?
an open circle.
Yep, and you can do your number line like that. That's fine. Open circle. Bless you. And which way would you shade?
To the right.
Yep, you're going to shade to the right. Now, extra example B. On the left-hand side, there's really something you should simplify before you do it, and that's the minus a minus. What does this left-hand side turn into? Yeah. What is it?
An addition sign.
Yeah, it's going to be an addition side. So what would you put on the left-hand side?
Minus, or P.
P plus 3. So that's what this problem really is. It would have been simpler if that's what they had done to begin with, but they didn't, so you had to simplify it. And now, how do you get the P by itself?
Minus 3 on both sides.
Yep. Minus 3 on both sides. And that gives me P is
Or less than 7.
not less
Greater
than.
than.
Greater than. Yeah. Be careful when you write like a greater than and a 7 next to each other. They can kind of look the same depending on how you make your greater thans and 7s. Make sure you can read your own writing. Okay, so that's solving inequalities with addition and subtraction. So reminder, tonight's homework, 2.2. Okay. Test on Friday. No review day this week because we had the Monday off, so tomorrow will be the last day of new material. And then we'll have our test on Friday. Okay. And I will be after school tomorrow. If anybody needs to come see me for extra help or just stop by to make something up, whatever you need to do.